In this video, we're coming to the end of our topic on exponential equations, and the applied types of questions are exponential growth and decay. You're probably already familiar with the graphs that we're talking about when we're dealing with growth and decay. Growth graphs look like that, and decay graphs are like this. You may have also seen them in science in any experiments you've done. Just a recap of some of the skills that we've done table of values, and remembering that exponential equations are things like this, where the exponent, the variable, the unknown, the x is up in the power. Whereas when we did straight line graphing, it was in this format, y equals mx plus c. So exponential, it's up in the power. We've been using techniques of graphing, using our graphics calculators and drawing sketches, using the calculators to work out x and y values, and interpreting what the different values mean. For example, when it's written in this form, what does that number at the front mean? Where on the graph is that? That's the y-intercept number. And so interpreting some of those things and then solving equations. So using our graphics calculators now to look at some applied problems. Okay, so we've got a lot to read here. An entomologist monitoring a grasshopper plague notices that the area affected by the grasshoppers is given by this formula, where A is equal to the area that is covered by the plague. So imagine all of these grasshoppers going crazy. In hectares. It's not a unit that we use all that often, but farmers do, and for large blocks of land. And it's given by this equation. So where n is the number of weeks after the initial observation. So notice n is in the power instead of an x, and it's that number of weeks after they first observed how many grasshoppers are there. So what are we expecting to happen? This is a growth video, so the numbers of grasshoppers are going to grow, increase. And so here are the questions that we're asked to do, the steps. So we're going to start by finding the original affected area. I want you to have a think about that. What happens for the original? That is on the graph, that's actually the y-intercept number. So how many weeks have happened at the beginning there? None. And so which variable is that? That's the n. So to do part A, we're actually going to substitute in when n is equal to 0 and solve for that. So here's one already prepared. Whenever you're asked to find something about the original, that's a key word for putting that variable is equal to 0. Just a reminder, here was the equation that we were dealing with, and what we've got written here is we substitute in where we saw n, we're putting a 0, working each of them out, because anything to the power of 0 is 1, or you can just type that into your calculator, getting 1,000. What units is that though? It's not dollars. It's hectares, and the abbreviation for hectares is HA. Because this is a worded problem, we like you to answer with words, so writing a sentence saying, find the original affected area, and therefore your answer is the original affected area was or is 1,000 hectares. Would be was, wouldn't it? Past tense. Part B. I've already written down the answers to speed this up a little bit for us. If you're asked to find it for 5 weeks or 10 weeks, which variable does that relate to? This is the n. So that's the number that we're changing. So you substitute it into the formula that we've been given. Where you saw an n, we're putting a 5, working it out on your calculators in the run mode and rounding. Now, if you've seen this squiggly equals, you may or may not have seen that before. That means approximately equal to. It can also be written like this with an equal sign, and then when you round, you put a dot at the top of the bottom. So it's approximately equal to 2,011 hectares. Has that number stayed the same or gone up? Yes, it's gone up. What about 10 weeks? What's the number now? 4,046 hectares. And how did we solve that? We substituted 10 in where we saw an n again. It's also possible to solve this on your graphics calculator. So graph it, and putting it in the graph mode, you would put it in y is equal to. Type in your numbers. Now you have to think about your view window here. When we're doing these graphs, we're often only interested in what we call that quadrant. I'm never sure which way to do this on the camera. And think about how many weeks. So part of the question had 5 weeks and then 10 weeks. So I would make sure your x-axis goes out to at least 10, probably 15 or 20. What about the y-axis? Well, the numbers that you were finding, if you remember, was 1,000 to start with, and then we went to 2,000 and 4,000. So my advice would be start at 0 and then go up to about 10,000. And you can put a scale on if you like, but that's up to you. So you've graphed that and got the view window right. How do you solve? We're solving for when the n value is 5 weeks. So we have the x value, we need to solve for the y value. And that's when you use your y calc option. That's in the G solve menu, probably have to arrow across one, and the y calc, and it will ask you for the x value. And for the first one here, you would type in 5. And as you can see, there's that 2011 number coming up. And then the second one here, again, y calc in the G solve menu for 10. And here's our number 4045. But as we noticed that would round to 4046. For numbers this large, it's fine to not include decimals. Think about that too. This is grasshoppers. This is approximately how many whole grasshoppers. We're not having half a grasshopper. So let's round correctly, rounding up or down. Then when you're asked to graph this, what elements do you need on your graph? This is a sketch, so it doesn't have to be completely accurate. One thing that we always need is the y-intercept. That number that we started with was 1,000 hectares. So making sure the scale on your graph matches that. Looking at the scale on the x-axis here, we've gone up by 2 weeks at a time. Labeling your axes, instead of x and y, we're going N and A for area. Units is also good too, noticing that we've got weeks. Noticing that the axes have arrows to continue on. They don't just end where you stopped. And then you want to plot your graph. So if you've found any values, put them on. And we did. In part B, we found that there was about 2,000 hectares after 5 weeks. So that lines up with 5. And after the 10 weeks, it was about 4,000. So you plot your points and then connect the dots to draw the graph. And putting an arrow on the end too, because the graph continues. Part D asks us to use our graph or technology to find how long it will take for the affected area to reach 8,000 hectares. You would have already seen that on the picture before, but let's talk about how to do it. This time round, what value is that? Is it the X or the Y? Well, this is the Y equivalent now, or the A for area, or the Y value. So we're doing the opposite. We are solving for an X calculation, and we have the Y value. So back into the G solve menu, type in 8,000 for your Y value and see what you get. So there's the 8,000 that you can see. You get 14.878. So you could round that to 15 weeks, but in this occasion, it's okay to have a part of a week. So it will take about 14.9 weeks to cover the 8,000 hectares. I'm adding this extra bit in for this example because I can see from the textbook you're going to get asked about expected percentage in a couple of the questions. So I want to remind you about how to do percentage. For growth questions, it will always ask you about the increase in that effective area from 5 weeks to 10 weeks. Using the values that we've found. What was it for 5 weeks again? How many hectares did it cover? You might have it written down, or I'll just remind you that it was 2,011 hectares. I'll write the units. 10 weeks. What number was it? It was 4,046 hectares. So you can see an increase. Oops, yeah, that's a 6. Do you want to have a guess how big that increase you think is, roughly? And let's see if you're right. How do we do it? When I teach percentage, I teach it like this. That's the change over the original times by 100. What do I mean by the change? It's the difference in the two numbers. We do the bigger number, take the smaller number. So let's start with writing just that. You write the bigger number, so for 10 weeks, or it's often the number that's further along in time. Subtract the smaller number, because when we go to do decay questions in the next video, it'll be numbers shrinking, getting smaller. So it actually will be the smaller number first. But anyway, in this one, it's fine. Over the original, what do I mean by that? It's the original number. So where did we start from in time? It was 5 weeks. So the 5 weeks number is this 2011, and multiply that by 100 to get it into percentage. Typing that in your calculator and you get 101.19%. So that's the increase that we've expected. I guess another way of saying that is double. You can see that the numbers have nearly doubled. In terms of a percentage increase, it's a 100% increase is also another way of implying double. So when you're asked to do a percentage, it's the change. So it's the difference between the two numbers over the original number that you started with, as in the one in time. Multiply by 100 for percentage. Answer with units and words. This matches 13E.1. Thanks for joining me.